So we're going to start by reading the doc. Welcome to this recording, meeting on generators. There you go. I'll set a timer.
Josh, feel free to delete my parentheses there if you want to fold it into your comment.
No, that's fine. Especially it helps with the attribution.
Right. We're 10 minutes have passed where people are starting to leave questions and put some answers. Shall we get started? Does anyone want more time to read?
I'm almost done. I'd like it,
All right.
I think.
Give it another minute. Speak up.
I would like another couple of minutes as well, please.
Okay, let's do two minutes to start. See.
I think, I don't know if Nico or Esteban is the one putting in the bits about forward at the bottom, but I would like to discuss that at some point.
I mean, I'm assuming we're going to go over each of the questions. So it's just
Yeah.
preceding a
which
little bit
bits
of
at the
answers.
bottom?
We'll discuss it. Don't worry about it now.
Yeah, sorry, I wasn't meaning to jump the queue. I don't want to pile in a bunch of extra text on top of that, I think.
Yeah, that's why I only wrote trying not to put long answers, just note interest. Anyway, we're 2 minutes in. Is there more time for reading desired, Josh, Felix, or others?
I'm okay.
Let's go ahead.
All right. So pulling from the queue, I don't know if we want to order in any particular way, but I think the first question.
Well, before we dive into the queue, do we want to give Esteban a chance to give us a tour and then we can dive into questions, or do we want to dive directly into questions?
I don't know that we need to do a tour given that we just read it, but Esteban, if you want to give a brief overview or have any particular comments, I think that makes sense. The other thing I would say is if there are short questions, like clarifying questions, that might be a good place to start. But
Right.
To make sure that if there was an intent to present the document along with some explanations, then let's give an opportunity for those explanations before we dive in.
That's fair. Do anybody feel like the document wasn't clear and would benefit from that?
I think, to me, the thing I might like to see at the outset is I wrote comments in line for things that just were unclear in the doc itself. Just a quick skim over I didn't want to put them as questions at the end because they didn't seem worthy of that. But even if you just skim over them and say yes, no, for the
why don't we go
comments.
over? Let's go over live, I guess. So.
Right. So I think I addressed that, but part of the idea is to make this. I've gone the two main things that are lacking on this proposal compared to the current nightly only generator feature is being able to return values through a yield point back into the generator so that you can affect its behavior and the return type. those are, depending on how we actually implement this, it may be problematic, but nothing here would preclude us from grafting on both of those features after the fact on this proposed implementation. The biggest problem I could see would be on the surface syntax, and that is not something that should be too problematic. And because this feature would be returning an inbuilt trait, we could expose different ways of consuming the generators, where you have a simplified version where you can only consume new elements, and a more elaborate syntax where you can actually affect the behavior of the generator.
Okay.
So I don't think it's a one-way door.
Right. No, it sounds to me like the quick summary then is, since this document isn't actually trying to, it gave us syntax, but said but it wasn't committing to it. It sounds like
Right.
issues here with generalized coroutines are more about, it sounds like the syntax you'd use for them, and thus we don't need to, it's not really, this document is not a one-way door in that sense.
Right.
Okay, that's all I wanted to hear for that. You might be faster, maybe, if we, there's a link at the
Yeah.
top that says 4 comments. If you scroll up, Nico, if this is Nico's screen, I don't know whose screen this is.
My screen.
It's Nico's.
I think
You
it's,
mean-
no, I don't see it on yours. Weird. There's a, oh, there it is. Yeah, if you click that, then you can just sort of go
Okay.
down and see all of them.
I see.
I just wanted to
So-
clarify.
Subset of applications, not of stream, but rather of applications that the end users would write. There are some.
Okay,
So,
it's more
it-
general. It's more general,
Yes.
but just, okay,
yes.
that's
So
all the
there is
clarity
there is an argument that can be made that this is a niche feature that isn't actually used, and that is only a concern for library writers. And from my searches, I've seen what you would consider an end user application, a service that actually needs to operate on streams and create their own stream. Stream is not the only thing that they have to implement. In many cases, they also have to implement async read and async write. But there are cases, I'm making the case that getting this right is a foot gun that would benefit from having a language.
Is it fair? Is it fair to say that the improvements you're talking about here are roughly in one-to-one correspondence to when people are implementing streams?
that
Oh, I
Yeah,
guess
so
mostly I was curious about my first interpretation of this when I saw subset applications. I thought it was saying subset application of streams, and then made me wonder about whether you're making some distinction there about how you might implement stream in general versus what you can express with the syntax that you're, with the semantics and syntax you're providing here. If there's certain things you'd be able to express by manual stream implementation that you wouldn't be able to express with this system.
I think there's some questions in that direction, like Mark's question.
All right, then let's wait until we get to
Yeah.
that then and scroll down.
Yeah, I
The
think
other,
that's also relevant to my question and the discussion that we were having on Zulip.
Okay, so let's move along. This was a detail about the Python code, I think, in terms of I didn't understand why join and intervals is there, and I didn't see it referenced anywhere, but I think it's because there's a typo in the line, the very last line.
Oh yeah, yes.
Okay, and then I think Scott has the last one. Way down.
This part could be done with a yes. The main difference. So yes, the thing with iter from fn is that you are limited. Iter from fn works great when you need to create an endless stream, for example, or some sequence, but it doesn't compose very well when you need to affect that behavior based on a set of initial
I mean,
constraints that are affected.
it would basically still like,
It would look
it would look
basically
very similar,
identical,
right?
yeah.
You eliminate like a little bit of
Yeah,
overhead.
yeah,
but
you saved defining the struct is all that I meant
Yeah.
there.
It's
Oh, I
also
see.
worth noting that like iterator or stream from FN is like a worse thing than iterator from FN because of semantics about how borrowing works for async, like our missing async closures feature, which is another thing that sort of comes up in passing in this doc and gets mentioned lower down.
Yeah. I would say that to me, the key point is that you still have to write it as a like function that, you know, manually encodes the state machine.
Yeah, that's what I was about to say. My point here was, I don't think it's particularly relevant that you have to define a type compared to manually state machining the flow.
Right. Okay, cool.
Also, I don't know. Oh, I'm adding this question at the bottom. Forget that.
So why don't we go? I thought Taylor's question is sort of like probably the most important in the sense of like how I understood it was kind of why now? Why do this at all? It's sort of the motivation question, right? And I guess Esteban, you started speaking to it already a little bit, but maybe you want to.
Yeah. So from interactions with people in the community on different on social media, through what I've been seeing on the async vision document exercise, there is a common pain point of people. First of all, pin is probably the one of the biggest pain points that people have when learning async await. That is both because the semantics are subtle and somewhat counterintuitive to what a person may think is in the first place when first encountering it. So, and one of the common cases where people have to interact with pin is when writing a new stream. The other thing is we've seen cases of people misimplementing streams or in such a way that it doesn't cause a compilation issue, it doesn't cause an actual incorrect observable behavior, but what it does cause is a very slow stream consumption. If you, there is a link, I think, earlier in the document that talks about one of those cases. So what I posit is that this is a common enough thing. It may be niche in the larger ecosystem, but it's a common thing that any microservice that has to deal with different connections will need. It's not just libraries that need to implement stream. And there is a problem with discoverability on one, these potential food guns, and two, how to actually implement these things. There are blog posts explaining how to write your own stream from scratch. There are a handful of different crates that let you actually implement this in or just sidestep the issue and give you what the language feature would give you. But again, you have the discoverability issue, and when you have multiple alternative implementations, you have the problem of, okay, which one do I choose? And on this is a part that I don't know if we actually want to tackle on this meeting, which is this document is heavily focused on the producing side, but you also have to keep in mind the consumer side, whether we would have something akin to 408. And I know that there is some contentiousness there for how that would behave, but having some expression to express, if you forgive the redundancy there, to express that concept, that would let us hide things like having to pin the stream before being able to iterate on it.
I think, I'm sorry, if I could stop you for a second. I want to say I think that this is answering a different question than the one I was asking.
Okay.
I'm not trying to figure out like why people want to not write streams by hand. I'm trying to understand like what is the specific sort of like user story where they're not being served today. and how can we meet those needs, if that makes sense. So in my mind, a lot of the people writing streams today manually aren't people who would be served by this feature, because they will continue to need to write streams manually for either performance reasons or details of the implementation. Like, for example, the stream I wrote above has a feature baked into it, and it has something where it doesn't pull the stream unless
Which stream?
sibling feature has. I'm sorry.
Which stream did you write above?
Oh, sorry. The appendix C.
This one.
Yeah. So appendix C was sort of my example of how today you can on stable without macros or anything, you can already write and sort of impulse stream if you don't mind the resulting thing has these sort of restrictions about being not conveniently nameable, and you can't add methods to it, and sort of all these other things that we have other sort of systems in the works trying to solve, like the type alias infiltrate system. So I'm trying to figure out what specific audience of people we're trying to target with a by providing this sort of MVP feature, who aren't already being served by things like this, or by the macro libraries, or some reason why those the macro libraries or this this proposal, my code example isn't good enough for those users, if that makes sense.
Yeah, it does. So I there are multiple things. One is in my eyes, discoverability. That is an issue. Once you're told how to do it, it's easy enough to go about modifying the example and getting what you wanted to do. But this is the same kind of ergonomic distance that you would have if we didn't have a closure. If you had to implement every closure as your own struct with its own, if you had to implement a struct for every closure that you wanted to use, then there is certain level of friction there that doesn't really need to be. And one benefit that I see from this is if we do go all the way to actually implementing some item syntax for streams, then we also get iterators almost for free, which also lets us simplify heavily any kind of. I think it would change dramatically how people write certain types of code.
I guess maybe that's something to push on, because I'm not convinced I agree. I think that most of the people who are writing iterators by hand today would continue to write iterators by hand if we had async gen fn or gen fn or iter fn or whatever we're calling
So
it.
I'm happy.
That is
I'm happy to
possible.
chime in on this one. I would love to never write an iterator by hand again. And if the syntax is good enough, then I doubt I would ever want to use an alternative unless the syntax isn't good enough.
So Josh,
add
where
one
do you
other-
write iterators by hand today?
Say again.
When do you write iterators by hand today? When do you write the actual implementation of the iterator function?
Generally speaking, when I'm trying to provide a data structure that has contents and I want to provide an iterator over those contents. So I end up with a foo type that has an iter method that returns a foo iter with a reference to the foo that walks over the foo and returns its elements.
Right. At least it's been my experience that when I'm writing those things, I also want to offer, for example, a debug impl or something that prints sort of the current state of that iterator. And I also want it to be, copy or clone, or I want it to have some other method to extract the intermediate value or something else, and I want it to be nameable to my users, things that I wouldn't be able to do if I didn't write it by hand.
Well, two things. One is I haven't tended to run into much other than, yes, most things should be debug. But the other is I think what you're capturing is a requirement for this syntax of maybe there should be a way to name the type that's being produced and to then further extend that type by saying, I also want that type to support debug. I also want to add another method to that type.
So the piece that gets complicated for me there is specifically for something like a data structure scenario, I feel like it wants to be double-ended a lot or to have an exact size because data structures reasonably often know that. That's what my question above is about.
Mhm.
And reversing a generator is, I assume, a very difficult computer science problem.
So I want to say two things. First of all, I often find myself writing small iterators. I don't know, often. I sometimes find myself writing small iterators using iter from function or other things, which works okay for like just anything where I don't, doing a depth first search over some structure, some graph or something like that. Effectively, not necessarily an actual graph, but like in the compiler, for example, we might be for walking through a list of predicates and I want to evaluate them one by one without forcing everything to happen up front. It works okay.
Also,
but
sorry to interrupt.
I would be
Nico,
happy if it were a
clarify, I'm
FN
not
star.
saying that to clarify, I'm not saying that use case doesn't exist. I'm saying that use case is already served for the case of async streams by the tools that we have.
Yeah,
So
I want to speak to that point specifically, which is just to say that I have pretty much not had any pretty much every conversation I've had with, I was going to say customer conversations, I'll just say that, with people about async, they all bring up writing streams and nobody's using those tools. I'm not saying that that's like, the reason for that is probably manifold, and we can maybe address it by pushing harder on the tools. But I also think there is like a legit, that's partly discoverability, as Esteban said, and maybe we can make them more discoverable. But I think it's also feeling first class and other more subtle things. Like it's definitely something that is hitting people a lot. And one way to address it, I think, would be to offer them nice syntax. But I do hear the concern that like we'll offer a nice syntax that they won't actually be able to use. That's not very appealing.
So one thing that I want to say, Nico, is Taylor has a point. It's very possible that the people that are currently served with implementing a new iterator or a new stream may not make the switch because one, they are already used to it. Two, they may want to support older RASI versions. Three, they may have very specific needs. But what the new feature would do is allow a lot of people that aren't currently writing neither iterators or streams, which would like to, but don't have as high a necessity and are put off by the current difficulty in writing them. It will just I've lost the sentence structure there, but it will enable all of those people. So the fact that there are people that currently aren't using it doesn't mean that they wouldn't use them in the future. This would be a bit of induced demand, if you will.
Yeah, to clarify, I guess I'm saying like, I think that the discoverability argument is good and it's probably the best one. And in addition to the sort of feeling first class point, I think that I feel like providing these tools via like clear standard crates and which is just impossible right now because there's at least 3 different definitions of the stream trait floating around in the wild, and so you can't write a single canonical library for all of this. Like, I don't know, I feel like as an ecosystem, we're like in a mess right now, and discoverability is incredibly hard, and understanding documentation, like there's no centralized documentation because you have to figure out which of 5 different libraries you're writing your documentation for, is like not going to be like this isn't a primary step in the solution of solving that problem. And the reason that these, like, there are other things that we can do that are lower effort than introducing native generator syntax that would have a lot more payoff, I think.
I think there's a bit of a, I don't disagree with that. In fact, I agree. However, I also think there's like a assumption that we can't walk and chew gum. Right, that we can't do some of those things and push on.
Yeah, I mean, if we think it's not going to use up a whole bunch of the lang team bandwidth to argue about whether it's async gen fn or async iter fn or async fn star, or whether yield can, like, what it returns and what happens when you use question mark in the body, and whether what the return type syntax looks like if we think that those things aren't going to like eat all of our time so that we can't focus on other things, then I mean, go for it. But I'm skeptical that that's like, I think that those things are going to occupy like a huge amount of bandwidth.
So
that would better be spent elsewhere.
So I'd like to interject for just a second here. I think it's a valid point, and I also think we may not want to spend the entirety of the meeting talking about whether. I think that the point of whether we should do this or not has been made, and we should seriously consider that. And in the meantime, we may want to take the rest of the meeting talking over, okay, conditional on if we decide to do this, let's talk through some of the other potential issues.
I think that's a good idea. Yeah, I think this
Yeah,
we won't reach consensus on this at this point. I agree.
Yeah, I'm happy
Right,
to
like-
table it. Sorry, I tried to take this offline and have it on Zulip beforehand, but I think I didn't quite succeed. So yeah, please have discuss the rest of the
It was a
questions.
good thing to voice
To
in the
be
meeting.
clear,
It's a
I
good
don't-
thing to spend time on. Just we did. I agree
Right.
with Josh that.
To be clear, I don't want to invalidate that point. I'm simply suggesting that we move on from that point for now and reconsider it later after we've talked through some of the other issues, which may give us some more color on that.
That sounds
Here's-
great. Thanks, Josh.
Here's a
I'll-
cute question. Why
I'll
is
certainly
for-
say that being able to use yield return in C# for iterators means that basically no one ever writes a manual iterator implementation because there's no point.
All right, so that is helpful. I think it's a good precedent to think about. But so the next, I'm going to go through the queued questions. It says, why does the desugared return into iterator rather than iterator? Kramer TJ.
So flexibility, one of them is flexibility. If we had to return, so if we were to return a specific impl iterator, then that's all that we could ever do. I don't know if that is actually what we want to do. It may be the moral equivalent to that, because it would be useful, as you mentioned earlier, it would be useful to be able to extend and potentially name that type. If we were to return something close to what a closure is or some other nameable type, you could actually extend it and have not only just iteration, but add extra methods to it. Now, why into iterator instead of iterator? Just flexibility and forward being able to change it after the fact. Those were the things that I had in mind.
Okay.
So it doesn't seem like returning impl iterator would prevent us from having that flexibility, in that you could always potentially have a name for that type elsewhere. We could have a syntax that allows you to name the type. I
Right.
think that into iterator just implies you're returning a thing that you can call a function to get an iterator from, but you're already a function that's returning an iterator. So if there were code to write, you could write it there. I'm not sure what the use case would be for it being into iterator or into async iterator that doesn't just add complexity.
Are there cases where the structure that you get from for iteration is different from the structure you get for async iteration, where you really would want that level to be abstracted so that you don't prematurely commit to one when you really wanted the other?
You can't interconvert. I think you're implying you could get an impl iterator or into iterator and then choose if you want it into sequential or async, right?
Based on the idea that if you have the name type, I guess, yeah.
Hmm.
Whatever the type, let's say you have the name type, either it's going to implement into iterator or it's going to implement iterator. And I'm trying to say that if you go with what Josh was saying, I think, of saying it's an iterator, does that mean you've now committed yourself down a path that you didn't want to be necessarily?
The only thing I would say is I don't know if this is a good precedent. I would have initially thought into iterator just because we regretted, I think, making ranges not into iterator. But I don't know if that's really a good
The
I mean, I think
the other
that's
side of
true,
that,
but-
the other side of
ahead,
that
Scott.
though is that part of what stalled the work for the addition to move dot dot syntax to being into iterator is that it means you have to call dot into iterator
Right.
anytime you want to apply other things on top of it. Like if you just want to, if you wrote your iterator and now you want to zip it with something else, well, zip's on iterator, not into iterator.
Right.
I think we should move to the next question. I'm mindful of the time, and I think there's a lot of good details. Like it seems clear that this is a choice that one would have to make. It may not be
Sure.
correct.
I think there's a lot of trade-offs to making it, and we should consider if we actually need to add that flexible joint at that point, or if the indirection is not adding anything.
In particular, I think the next question applies.
Lending iterators also make me very curious about how that should work. If
Very
we
good
can ever
point.
do those from generators.
Yeah.
So,
So this isn't the next queued question, but the next couple were mine, and I think that this one is more important from Scott, so I bumped it up the
Yeah.
queue.
okay, cool. So this was about adding methods, like size hint and so forth. And I think that's relevant to the previous question. That's why I wanted
And to
move
Kramer's
less.
question, I think, as well.
Yeah, because if we return into iterator, even if you had a syntax for naming it, that's actually not, you're not naming, the thing you're returning is not the one that will add these methods, right? So you couldn't implement them by hand, or at least it would be a little trickier. You'd want to be implementing on the iterator that will get yielded by the into iterator. But that said, I just want to say, it seems like you could imagine allowing us, if we had like named impl trade or some of these other features, you can certainly imagine allowing you to write impls on them.
I think the thing I'm confused about is how we would handle accessing captured values inside those impls. Because I'd imagine like for size hint, you need to take advantage of the fact that, for example, a range inside of your generator has advanced.
I would add
And-
this is
and so
totally
you need
applicable
to
to
access,
closures,
like, the
right?
current state of that range somehow, right?
Yeah. And I just want to say this is totally applicable to closures, right? Like we have the same problems now, I think.
Yes.
And it's come up that we, for example, implement clone automatically, but that's not always a good thing, and so forth.
It is worth noting that I think it would be sort of pretty sad, like if map can look a lot nicer as a generator, I think, in many cases, just from like a looking perspective than a map call, but you'll get, potentially many more allocations or whatever else if you're collecting that iterator or stream because you just lost your size hint by default. And I struggle to imagine that we can do anything in the compiler to avoid that.
I also think for things like map specifically, like you want to optimize the layout of it because it's a really commonly reused, like those sorts of building block things are used heavily everywhere, and we wind up with like accepting PRs to do this sort of like smallest micro things to reduce a branch somewhere because it made somebody's thing optimize better. And we wouldn't, like in practice, we wouldn't write those things as.
To be clear, when I say map, I mean like I have library code that has some thing that I'm mapping to some other thing. So I'm not like writing the map itself. I want to sort of use map.
Yeah, but I think in the case of async right now, the ecosystem's at such an early stage that a lot of the things people are struggling to build are these like really early building block functions.
Yeah, I think the situation may be different for async than for iterators in that case.
I don't totally buy that point. I mean, I'm looking a little bit ahead, let's put it that way. And I think people are building a lot of stuff in async, some of which is building blocks, some of which isn't. But I do think the point of, this actually comes to the Rust guiding principles meeting. I think one of our guiding principles of our design has always been efficiency is idiomatic. Use iterators, not just because they're nice to use, but because they yield better code. And I wouldn't want to see us regress on that point. We should at least be able to provide those sort of hints so that using the nice thing doesn't cut you off from it. I think that's definitely a design requirement we need to add.
Yeah, we do have some small problems with that for iterator already, because if you return impl iterator, you've lost some of the things like exact size or
Yes,
double-ended or
right.
conditional, or so maybe part of that.
That's
I guess
only
that
sort
wouldn't
of
solve it
true,
for
right?
generators if we fix that for Impl.
Some of the stuff today specializes, so it bypasses the like visible barrier in some sense. Like you don't know it's an
It's more
exact
like the
size,
extra methods.
but your collect knows so it doesn't actually lose any performance.
True.
Right.
Unless your
In the
caller needs
cases-
to use it somehow through a way that's not
Sure.
specialization.
Yeah.
But yeah,
All right, I think we answered this question. I don't know who's typing this hypothetical proposal, but do you want to talk about it? Or
That
is it-
was me. I don't necessarily know that I have a precise syntax proposal here so much as I wanted to point out that if we had generators returning something that was an iterator, where it could either be an anonymous iterator with impl iterator or a named iterator type, then we would have the option of subsequently implementing further things on that iterator type so that you could add things like size hint after writing your generator function.
Yeah, I think the problem, Josh, is that like we were saying for closures, like you don't have the ability in the body of size hint. You would need to access state that's inside the iterator generator, right?
Yeah, we
And
have to
don't
add a
have
way to do that.
syntax
So
for
what I was imagining was some way to say under there's some like one of those Zen cone things where it's like, you know, every lambda is actually an object and every object is a lambda and it's just a matter of, you know, what methods you attach to it. I was imagining something where for closures you'd be able to throw on extra method definitions and you just within the body of the lambda and be able to reference the captured variables within there. And likewise for generators, I guess it would be a method definition in between every yield point or something, because you have to, you know, handle it for each distinct state machine, but it doesn't seem like an unsolvable problem. It just seems like another syntax bike shed to be had.
Right. Another approach,
You
by
mean-
the way, would be if we inverted the flow of syntax there, where rather than having a top level generator that impled iterator, you could have an impl of iterator for a type, and then a instead of having to hand write the iteration functions, you fill it in using generator syntax saying this is how I want to implement this.
Yeah, I was thinking about that.
if we
Yeah.
had an expression for this, would that avoid a bunch of the syntax questions or the problems like whether a generator function should return impl iterator or impl into iterator or whatever?
I'm certainly
mean,
tempted
just
by the idea
generator
of
block
only
rather than-
having a block and not having a function syntax, and then it's easy enough to wrap a function syntax around it.
I assume there's some funkiness for
doesn't-
async though around lifetimes.
I don't
I
understand
think
this
it's
might
just
make that
gen
harder.
async, right? Is how you'd spell it, right? Or something like that. And then you'd have gen blocks. And they
How
would
does that
act
give
like-
you solve the problem of
Doesn't
adding
solve
new?
any of these
It
problems.
means you don't have to solve the problem of the return type syntax because you don't have the sugar for function signatures.
I think
I
that
don't think it solves the size hint though, I agree.
it doesn't solve the size hint, and moreover, in a way, it makes the return type harder because you don't have to write it. So like, if you want to use it to pick things, you can't. I don't know. I don't think it solves the interesting problems fundamentally.
No, it just sidesteps syntax bike shed.
Well,
Yeah.
it's not just that.
Sort
It would
of.
also give just enough language support to let you write the actual iterator block, such that then it would be easy to invent whatever I want to write an iterator you want using a proc macro or similar. You could have a proc macro that results in defining the my iterator type and allows you to define things like size hint and state and introspection and similar.
Yeah, but you can
And
do that with
then-
a genfn.
Yeah, you could do that in either case, I think.
True, but what I'm suggesting is that if we had just enough syntax support to do iterator blocks, that then allows for a lot of experimentation in the ecosystem for the next round of what should the top level syntax look like. We might then one day adopt a top level syntax, but we might be solidifying too much too soon if we add it now.
Yeah.
Sure, yes, I agree. I agree
That's
in that
fair.
I think it could help avoid some of the syntax questions.
In particular, I feel like the block syntax solves a huge fraction of the problem of it's painful to write an iterator or a stream, and then anything beyond that is additional ergonomic improvement and additional expressiveness improvement. But the biggest part of the problem that people are complaining about seems like it might be solved by a block.
I'm not totally convinced that that totally sidesteps everything, because I think you still need some way to annotate the return type so that we can have correct question mark error type inference.
No argument there. There are a lot of
I'm
details
also not
to
sure
work out. I
how
just think it might
I'd
work.
store the generator inside my iterator, because the generator needs somewhere to store its state.
I don't think this is about that question. Scott.
I think we should sidestep this question. And I mean, I do think this is a
Great.
good theme, but I want us to, we have 4 minutes left and I'd love it if we can hit a different one.
Regarding size hint, before we move on, is the concern only for cases where the programmer would have to determine what the size bounds actually are, or is it also about propagating consumed iterator that is being yielded and propagating that size hint outwards? Because that second case feels to me like we could support.
I'm not sure how you would. For example, if you iterate over 2 streams in sequence, right, you want the generator to give a size hint that is the first plus the length, the size hint of the first plus the size hint of the second, right?
Right.
And there's no way, I don't know of how we would infer.
Well, you
that.
would have an iteration expression on both of those. So on both of those values, you would have an iteration expression that would have a yield in its block. So you could just call quote unquote all of the iteration expressions that have yield and see at a peak at the type to get the value of the size hint.
But you might not have even created the second iterator yet, right? Like you need, like there would need to be some sort of hints from the programmer, like.
I think we can.
I guess so. But
It
yeah,
seems like it would be possible. Well, I guess what Josh is writing already. You can imagine some cases where we might be able to infer, but
not all.
certainly not in the general case. I think we kind of covered this question. Maybe we've already covered all the main big questions. Are there any questions that people feel they wrote that are just like different than what we've talked about?
Sorry, I'm scrolling back up to read the questions there at time.
Yeah.
I did kind of want to talk about that 408 thing, but we can talk about it on Zulip.
Yeah. Well, we only have 2 minutes anyway, but we could do that. Let's talk about 408 real fast.
Oh, and also I'm assuming for the MVP, I just left a comment here. Yielding borrows is into the stream state is out of scope for this, right? Since we're just considering async iterator and not async ref iterator or whatever we're calling it now.
Iterator.
Lending iterator or something.
Lending, thank you. That's the name we use now.
I think that's correct.
It's like
But-
it's like GAP. We're gonna be calling it the old name for like.
But I do think lending
Right,
iterators, like I think it's out of scope, but I think it's a good example of like, we should leave syntactic
think-
space to not have to infer whether it's a lending iterator or not.
Right, we would really like for that to just be easy and natural, that one thing yields, owned values and one thing yields borrowed values. Like, because I think the borrowed value thing is something that I really frequently want, and yeah, I would love for that to be supported.
I would like to
So-
ask,
Yes.
Never mind. We're at the end of time. I'll move it to Zulip.
Sorry.
It's all right. That was a good final question. We can follow up on the 408 stuff on Zulip. Thanks everybody for a great call.
All
That
right.
was really fun.
Yeah, thanks so
Thanks,
much for your time, Esteban.
Thanks,
No, of
Esteban.
course.
Absolutely. Thank you, Esteban.
Thank you all.